Hello all, a very good day to all of you. In this session, we will discuss all the questions that have come from analog circuits in 2018 GATE examination for electrical engineering branch. Okay, and in 2018, right, there are three questions that have come from analog circuits. Right, two are of 1 mark and one is of 2 mark. So total 4 marks have been asked from this subject. Okay, so let us discuss all the question one by one. The first question is, the op-amp shown in the figure is ideal. Okay, and the input impedance V in by I in we have to find out. Okay, so first thing is, since it is an ideal op-amp, the gain of the op-amp is infinity, the bandwidth is infinity, the input resistance is infinity, and the output resistance is 0. Okay, 0 ohm. Okay, and we could see there is a feedback from output to input, which is negative terminal. That means there is a negative feedback in the circuit. Okay, but you can also see there is a feedback from output to positive terminal also, right? So then you should not be confused whether it is negative feedback or positive feedback. Okay, so why it is so? If both positive feedback and negative feedback is there, in order to determine what is the overall feedback, then you have to find out the feedback factor. Okay, if the negative feedback is more compared to the positive feedback, then it is the overall is negative feedback. If the positive feedback factor is more compared to negative feedback, then it is overall is positive feedback. Okay, so in this circuit we could see what is the negative feedback. Output to the negative terminal is, so let us calculate. Okay, so my V negative is equal to negative feedback is how much? Okay, V negative is equal to V output into R2 by R1 plus R2. So negative feedback factor beta negative is equal to V minus by V0 is equal to R2 by R1 plus R2, right? This is negative feedback factor. What is the positive feedback factor? You see, there is a output to positive, there is a feedback, and whenever I wanted to calculate the positive feedback or negative feedback, I have to sort the input. Okay, so in this case, what you have to do? This is my op-amp, this is positive terminal, negative terminal. This is my R2 R1. Since I have to sort the input, so it should be grounded. Then there is a Z. Right? We could see what is V positive. V positive is equal to V0 into, this is 0, right? The resistance is 0 by 0 plus Z. So Vg plus by V0 is equal to 0. Okay, so that implies positive feedback factor beta positive is equal to 0. Okay, and since you see positive feedback factor is 0 and negative feedback factor is some quantity, so beta minus is greater than beta plus, so the overall circuit is in positive feedback, sorry, negative feedback. Since the feedback factor for the negative feedback is more compared to the feedback factor for positive feedback, so the overall is in negative feedback. Okay, so whenever you are confused whether to determine whether it is negative or positive feedback, you have to follow this procedure to know the overall feedback. Okay, so since it is negative feedback, right, so we know, and it is a ideal amplifier, so it obeys the virtual ground principle perfectly. That means the voltage at the negative terminal is equal to exactly equal to voltage at the positive terminal because it obeys the virtual ground principle. So what is the voltage in negative terminal, guys? V negative is equal to V0 into R2 by R1 plus R2 ratio divider, right? This is equal to my V positive also. Okay, so this implies V0 is equal to V positive into R1 plus R2 divided by R2. Okay, so now let us apply a nodal equation at positive terminal. Okay, so nodal at positive, the current coming is minus IN plus current going away is plus, it means is V positive minus V0 by Z is equal to 0, right? This implies IN is equal to V positive is how much? V positive is, okay, V positive is 3. Okay, V positive is V positive minus V0 is V positive into R1 plus R2 divided by R2, okay, divided by Z, right? V positive is V positive, V0 is I put this one, this equation put here, then by Z, okay. So R2 into V positive minus V positive into R2 will go but cancel, okay. R2 into V plus minus V plus into R1 minus V plus into R2 by R2 will come below R2 into Z, okay. So this R2 and this R2 will get cancelled. So what I have is V in is nothing but V positive, right? V positive is nothing but V in only. So V positive by I in is equal to V in by I in is equal to R2 into Z minus R2 into Z by R1, right? Correct? See, I in is equal to minus V positive R1 by R2 into Z, okay? So V positive by I in is R2 into Z divided by minus R1. So it will be minus R2 Z by R1. So the answer should be B. Right? This is a very easy question. Okay. Only thing is you have to know the overall feedback is how much. Okay. Let's see the next question. In this question, okay, a single fully controlled rectifier is supplying a load with a anti-parallel diode, right? As shown in the figure. Okay. All switches are ideal, right? Which of the following is true for instantaneous load voltage and load current? Okay, since you see this is a control rectifier, okay, and it allows current only in the one direction, right? Only from anode to cathode. Okay, so let us discuss two conditions. The first condition is, suppose that V in is positive and this is negative, right? If it is positive and negative, what will happen? This will be off, right? This will be off. And since it is positive, this is anode, so this will be on. This will be on. Since it is negative, so this will be off. This will be off. And since it is negative, this will be on. Okay. So now we see how the current will flow. The current will flow like this, like this. This is off. The current go like this it will go. And since it is positive will come, this will be off, right? Because this is positive means this positive minus something will be positive here, so this will be off. So current will go like this to the load, okay, then like this, then it can go like this only because this is off, so it can go like this, okay. This is the loop for the current to flow in the whenever V in is positive compared to this negative, means V in is positive, then V in is positive cycle. Okay, this is the condition when V in of positive cycle. Okay, the current will flow from like this, and this diode, this will be off, this will be off, and this will be off. Okay, so and V in will be V in minus something will be V0, right? V0. So V0 will be positive, and I0 also will be positive because I0 is flowing like this only because the current is flowing like this only. So I0 is positive and V0 is positive, right? So V0 is greater than 0 and I0 also greater than 0 because current is flowing like this only. So I0 is positive and V0 is nothing but like this only because positive will come here, positive will come here. So V0 is like this only. So this is the condition. When V in negative cycle, negative means this will be negative, this will be positive. When this is negative, this will be off, right? Anode will be negative, anode will be off. This will be on, right? This will be on. When it is positive, this will be on, this will be off, right? So since it's positive, current will go like this, go like this. Since this is positive, positive will come here. This will be also off. So current will go like this, current will go like this, current will go like this. Then here it cannot go like this because it is off. So it will go like this. Okay. So this is the path of the current when Vn is negative. Okay. So here also you see when Vn is negative, right? Then also I will get V0 is positive because this is positive, this is negative. Positive minus some drop. It is ideally there is no drop. Okay. This positive will come here. Here also positive, V0 will be positive and I0 also will flow like this only. So here also V0 is greater than 0, I0 is greater than 0. So in both conditions, V in positive and V in negative, the current is flowing through the load like this and voltage also is developing like this. Okay, so this is the condition. You see, V0 is greater than 0, I0 greater than 0. Which one is C, right? C1. Option is C. And in control rectifier, V0 is never negative, right? Because always current is one time the current is flowing like this, and another time the current is flowing like this. Okay. So it's a 2-mark question. In the circuit shown in the figure, the bipolar junction transistor BJT has a current gain beta of 100. Beta means the collector current divided by my base current. This is my collector current. This is my base current. This is my emitter current. Correct? The base emitter voltage drop is 0.7 volt, right? 0.7 volt. We have to find out the Thevenin equivalent resistance RTH shown in the figure from this terminal. Okay, this you have to find out. Okay, so for we know the Thevenin equivalent resistance is nothing but my open circuit voltage means whichever terminal I have to see that terminal I have to open means AB is already open. Okay, across this I have to calculate the voltage, open circuit voltage. Okay, then my short circuit current. Short circuit current means I have to short the terminal across which I want to calculate the Thevenin equivalent resistance. Then I have to calculate the current. Okay. So then if I calculate open circuit voltage and short circuit current, then the Thevenin resistance is VOC by ISC. Okay. So first let us calculate the open circuit voltage. Open circuit voltage. Okay. So open circuit voltage means I have to calculate the voltage across this 1K. Correct? So for that, let us apply some loop here, right? This KVL we will apply here. Okay, 10 points, 10 point. So KVL, okay, in this loop, 10.7, 10.7, right? Minus this is base current, IB into 10K. Okay, minus the minus I. Okay, this is around so 10.7 minus IB into 10K minus VB minus IE into 10K. IE into 1K. 0, 0. I put a KVL here. 10 minus IB into 10K minus VB minus IE into RE is equal to 1K is equal to 0. Okay. That also we know this implies 10.7 minus IB is nothing but we know IB plus IC is equal to IE, right? So IB plus IC is beta into IB is equal to IE. This implies IB is equal to IE by 1 plus beta. Clear? So I put IE by 1 plus beta into 10k. VB is 0.7 minus IE into 1k is equal to 0. Right? So this implies 10 minus 0.7 is 10 volt is equal to IE into 10k by 1 plus beta. Beta is 100. So 1 plus beta is 101. Okay? Plus 1k. Clear? So what is IE? What is IE? Calculate. IE is equal to 10 volt divided by 10k by 101 plus 1k. Clear? So let us calculate that one. So this will be 10 divided by 10k by 101 is nothing but 10 into 10 power of 3 divided by 101 plus 1k. 1k is nothing but 1000. So I got 9.09 milliampere. 9.009 milliampere. Okay. So 9.09 milliampere is this one. So what is VOC? VOC is nothing but IE into 1k, right? IE into 1k is my VOC. VOC here. VOC here. So it's equal to 9.09 milliampere into 1k is equal to 9.09 volt is my the open circuit voltage. Okay. Let us calculate the short circuit current. So we have to calculate the short circuit current. For that, I have to short the terminal. Okay. When I short, this 1k will go away. 1k will go away. Now again put a loop equation in this equation. Okay. KVL in this loop. Okay. 10.7 minus IB into 10k, right? Minus 0.7 is equal to 0, right? Because this is 0, this is grounded. This is my ground. So 10.7 minus 10 IB into 10k minus VB is equal to 0. Simplice IB is equal to 10 minus 0.7 is 10 volt by 10k. So 10 by 10 is 1 milliampere, right? So 10.7 minus 0.7 is 10 volt. IB is 10 volt by 10k is equal to 1 milliampere. So what is IB? IE is 1 plus beta times IB is equal to IE is nothing but the short circuit current is my circuit current. So ISC is equal to 1 plus beta is 101 into 1 milliampere is equal to 101 milliampere. Okay. So this is my IE. Okay. Now I have to calculate RTH. Okay. VOC by ISC is equal to 9.09 voltage by 101 milliampere is equal to, let's put this 9.09 voltage by 101 into power of minus 3 100 milliampere is approximately I am getting 90 volt. Okay, 90 volt is my answer. Okay. 90 ohm. Okay, simply first thing is I have to calculate the open circuit voltage when A and B are open. Okay, then I got open circuit voltage is 9.09. Okay, now I have to calculate the short circuit current by shorting the terminal across which I have to calculate the Thevenin resistance. Then the short circuit current is 101 milliampere. Then its EG is RTH is open circuit voltage by short circuit current give me 90 ohm. Okay, so thank you guys.